Wonderful woman. Beautiful woman. Beautiful woman.
Hello, everyone. Thank you for joining. We're just going to wait a few more minutes and then we start.
Every day in the mirror, I see a woman. And every time I look in mama, I see that woman. A wonderful woman, an African woman, mother of nature. Beautiful woman. Beautiful woman. Wonderful woman. Beautiful woman. Beautiful woman.
Welcome. Thank you for joining us this afternoon. It's a pleasure to host again, the second in the series. Before we begin, I just want to wish all women here a happy International Women's Day. Women everywhere are fantastic. We are resilient, we are hardworking, we are strong. And as a health worker myself, I feel that the best honor we can give to women is to make sure that women everywhere get the same standard of care that will help them to live a full life, to enjoy their lives, to be with their families, and to not die anymore from diseases like preeclampsia. So it's my privilege to wish all women here a happy International Women's Day. I hope you marked the day, and I hope that this year we can actually make a difference in the lives of many women in Ghana and across the world. Thank Thank you for making time to join the second series of our Knowledge Cafe. A little over a fortnight ago, we began our fun series on the omics of preeclampsia. So last fortnight, we looked at the genomics of preeclampsia, and that was really interesting to look at the genes and mutations and how genetic profiling can actually help us understand women that are at risk of preeclampsia. And this week, our session is going to be on the metabolic pathways of preeclampsia. I'm really keen to learn how real-time biochemical activity can help us detect warning signs of preeclampsia. And as a midwife, I find metabolomics really important. And I just want to know more about its utility in clinical practice, especially regarding simple urine and blood tests that we can use for risk stratification. So it's a pleasure to have you here, and we hope that more people can join us. Next slide, please. Before we begin, and to make sure that we have a seamless and enjoyable experience, please make sure your microphone is muted. Along the line, when the presentations are ongoing, we really encourage you to type your questions in the chat. At the end of the presentation, if we have enough time, we will invite a few people to unmute themselves and ask their questions. And please remember to mute yourself again after you've asked your question. This meeting will be recorded. Like our other webinars, we always record it, and it is available online through the APEC Ghana website and our social media pages. If you don't want your name or video to be visible, please turn off your video or make your name anonymous. Like you can just put your first name or your initials. Next slide, please. So this is our program outline. I'll take you through a bit of icebreaker questions. We'll have a survivor share his story with us. That's a new thing we've added to our Knowledge Cafe series. Then we'll run through the theme, the purpose, and the outcomes of this session. I'll briefly introduce our speakers. We'll have our first speaker present, and then the second speaker will also present. And if we have enough time, hopefully, we'll take a few of your questions, and then we'll run you through the closing section of the Knowledge Cafe. Next slide, please. So this is the fun part where I get to hear from you. I get to know you a bit better. So please go ahead and type in the chat. Where are you joining us from? Which country, region, or which town are you joining us from? Go ahead and type in the chat where you're joining us from. I will begin. I'm joining from Darwin in Australia. It's currently 2 a.m., but I love being a host for this APEC Knowledge Cafe, so I'm ready to sacrifice my sleep and literally burning the midnight candle. So where are you joining us from? Okay, so from Dar es Salaam, that's phenomenal. Thank you for joining us. And we have a couple of midwives, Josephine from Ghana, thank you. Rita from Ghana, thank you for joining us. So we just want to hear from you. Type in the chat where you're joining us from. At the last APEC Knowledge Cafe 2 weeks ago, we had a lot of midwives, a lot of doctors, but a lot of people also joining from different countries. All right, so Mawena says she's a physician assistant. Eric is joining from Kumasi. Thank you, Eric, for joining. Albert says he's joining from Kilimanjaro, Tanzania. Wow, that's impressive. Thank you for making time to be with us. Lots of Ghanaians, Edith and Pat, thank you. Betty, thank you. Florence, a midwife, thank you. Daniel is a physician assistant. Thank you, Daniel ACN. Michael is also a physician assistant. Gifty is also a physician assistant, all from Ghana. Thank you for making time to be with us. It's always a pleasure to have you. So just type in the chat where you're joining us from and what your profession is. And just feel free to go on and tell us what you hope to learn today. 2 weeks ago was mind-blowing. Like, we learned so much. And this week, I know that it's even going to be better. I'm really excited. So you can drop a fun fact about metabolomics in the chat, or you can just tell us what you're hoping to learn today. So I was reading somewhere that genomics is like reading a cookbook. So it tells you what ingredients are available and how they might be used. But metabolomics is like checking the kitchen. So you know how when your mom is making that nice jollof rice and you go to the kitchen and then you see what's actually being cooked, you get like to see the real-time events of how your mother is adding the onions to the oil and the tomato paste and all of that. Yeah, that's how metabolomics is like real-time chemical processes. So that's my fun facts. Aminata says she's joining she's a physician assistant also from Ghana. We have somebody from Noguchi, Nanaya, a research assistant. Thank you for making time to be with us today, and lots of midwives. So thank you so much. We are so excited to have you. And along the line, I will still be engaging you in the chat to know where you are from and what you hope to learn today. All right, next slide, please. So the theme of this Knowledge Cafe is the metabolomics of preeclampsia. And these are our objectives. We hope that we can bring health professionals and other caregivers in the maternity health space together. And why are we doing this for? To improve their knowledge, because we know that if knowledge improves, it kind of translates into care also. And we want to have more quality care for women who develop hypertensive disorders of pregnancy. Next slide, please. Again, we also want to gain a deeper understanding of all the pathways that contribute to the pathophysiology of preeclampsia. And we are also hoping that as clinicians who are joining us, you can gain insights into how you can incorporate this into your clinical practice to improve management of women with preeclampsia. And lastly, we are also hoping that as we get to know more about metabolites and all of that, we can also improve our knowledge of biomarkers that aid in the diagnosis of preeclampsia, especially with regard to early diagnosis or risk assessment of preeclampsia. All right, so Lusago says, I hope to learn novel and promising biomarkers to predict preeclampsia. Same do I, Novel, and same do I, Lusago, and hopefully we'll get to hear more about this. Next slide, please. So my name is Isabella Gatti, and I'm your moderator, and I'm ably assisted by Dr. Jeffrey Ahin, who is over in the Netherlands. So we have you covered for the next hour or so, and we hope you have a pleasant experience with us. Next slide, please. All right, so at this point, it is my privilege to introduce our first speaker, Dr. Vincent Ama, who is a senior lecturer and currently the head of department, medical biochemistry at the University of Ghana Medical School. So Dr. Ama, over to you. Would you like us to share your slides, or you're happy to do that?
Thank you very much. I think I'll be happy to share it from my end, if that's okay with you.
Great. Yes, sure. Over to you then.
Okay, I guess you can see my slides now.
Yes,
please,
all
can you
good.
see my slides?
Yes, all good.
Okay, great. And is my sound okay? Just to confirm.
Yes, loud and clear, we can hear you.
Okay, great. So I'm Vincent Amat, from the Department of Medical Biochemistry, the University of Ghana Medical School. So in addition to teaching, we work closely with physicians to conduct research on disease conditions that are relevant to the population. And so when I was informed about the opportunity to present on preeclampsia, especially using metabolomic approach. I thought it was an exciting opportunity, so I decided to agree and partake. And I want to use this opportunity to thank the organizers for such an opportunity to provide some insights on using metabolomic approaches to trying to get diagnostic information and possible treatment intervention for preeclampsia. So today I will, as a form, an outline for this presentation, I would talk briefly about preeclampsia. I appreciate the fact that most of us are coming from diverse backgrounds and mostly from the medical field. So we do have some comprehensive understanding of preeclampsia. But I would go through preeclampsia mainly to highlight some points which I think will be relevant for today's topic, that's using metabolomics. So that's the approach I'll be using when I talk a little bit about preeclampsia. And then gradually we'll come to how we could utilize metabolomics to identify some biomarkers and also give clues to treatments that could be used for preeclampsia. So for a start, I think I would just start right away. So preeclampsia, we are all very much aware that it's a complication which arises during pregnancy. And one of the very key hallmarks or symptoms of preeclampsia is high blood pressure. We'll come and see why that is the case in the next slide. But we all know that high blood pressure is one of the key hallmarks or characteristics of preeclampsia. And in school, we are usually told that the usual blood pressure should be, the systolic should be below 140, 120 millimeter mercury, and then the diastolic should be a little below 80 millimeter mercury. So whenever we are clocking above 140 millimeter mercury and 90 millimeter mercury, then we say you are almost approaching stage 2 hypertension, which is going to be a problem. And we'll also come and see why that is the case. Now, another issue with preeclampsia coming from the perspective of biochemistry is that it affects multiple organs. So over here, we could see the kidney, and then to my left, we could see the liver. And of course, it's not being shown here, but the brain and then the heart are also some of the organs that are being involved in preeclampsia. So this also is very, very important because all these organs are playing specific roles in the body. And if they are indirectly or directly affected by an underlying condition in pregnancy, then it means it could perturb or it could affect the proper function of these organs. So we'll come and also look at this from the biochemistry point of view to see how that could help us get hints or clues to getting diagnostic markers for preeclampsia and also getting suitable therapeutic regimens as well. So I mentioned earlier on the previous slide that high blood pressure is one of the key characteristics of preeclampsia. And why is that the case? So over here, we could see that one of the characteristics of preeclampsia is that the blood vessels becomes narrowed. So when the blood vessels becomes narrow, then of course the pressure of the blood flowing through these vessels becomes very high. So that's one of the bases for the increased blood pressure in preeclampsia patients, mainly because there is vasoconstriction. The blood vessels becomes narrowed. Now, if the blood vessels are becoming narrower, it also means that it's because the pregnant woman is responding to some factors that are being released by the placenta into circulation. So there are some conditions, some factors which are being released, and these factors eventually can lead to vasoconstriction. So again, vasoconstriction and high blood pressure is not only unique to pregnant women. In fact, old age and some other disease conditions also have hypertension as part of their symptoms. But then in the case of pregnant women and specifically preeclampsia, it's also because the vasoconstriction or narrowing of the blood vessel is caused in response to some factors that are produced by the placenta. And then coming from the biochemistry point of view, it means that this is very, very important, because then if you are able to find out what these factors are, we could use these factors as biomarkers for precise diagnosis of preeclampsia. Now, as I mentioned in the previous slide, I mentioned that diverse organs could also be affected. Over here, we are seeing the kidney. Over here, we are seeing the brain as well in the middle, and then the heart. Now, all of these organs, they receive blood. And if there is high blood pressure, it means you are affecting the flow, smooth flow of blood to organs. So, of course, since the kidney, the brain, the heart, they all rely on efficient blood supply. When we perturb or when we affect blood flow to these organs, it means you are going to affect the optimal functioning of these organs. And if this is not well taken care of, or much attention is not given to this, eventually we could see complications in these organs, which could lead to organ failure as well. Now, finally, preeclampsia, our focus is in pregnancy, so pregnant women. So again, I just mentioned that the key hallmark or key symptom of preeclampsia is high blood pressure. And high blood pressure means we are affecting effective blood flow. So in this case, the fetus as well, if there is impaired blood flow to the fetus, because the fetus doesn't feed directly, the fetus doesn't breathe directly, the fetus depends on nutrition from the mother, nutrients from the mother, and oxygen from the mother to survive. And all of this is carried through the blood to the fetus. So again, when the blood flow to the fetus is impaired, it means that survival of the fetus is also going to be compromised. So again, these are some of the things which I believe most of us are already aware of, based on our background coming from the medical field. But again, just bringing all of this out at this point in time, just so we could see how we could utilize metabolomics to help improve diagnosis and treatment of preeclampsia. So over here, I'm giving some very little basic information before I delve into the technologies we use. So again, preeclampsia accounts for it cause complications in about 3 to 5% of all pregnancies globally. So it's not actually a condition which is restricted to a particular geographical location. It's actually a global burden. So that also shows that attention to understanding this pregnancy complication is very, very important. And it's actually one of the leading causes of maternal and perinatal morbidity and mortality. So there are some deaths which are associated with preeclampsia, and that's worrying, because if pregnant women are dying because of complications from the pregnancy, especially preeclampsia, then we have to think twice about how we could step in and intervene to reduce mortality associated with preeclampsia. And again, the second point also goes to highlight the fact that even mothers and children who survive the pregnancy, they could be at risk for increased cardiovascular diseases, even in subsequent years after the pregnancy is even successfully bypassed. So this shows that preeclampsia is also a risk factor for life after pregnancy for both the mother and then the children. And of course, since preeclampsia is a complication from pregnancy, it's received attention from diverse sources trying to understand the pathogenesis of the disease and how interventions can be elucidated to help our women during the critical stage, such as pregnancy. So, like we were informed 2 weeks ago, there was a webinar or a seminar on genomics on this platform. And of course, genomics is one of the major approaches that is used in biomedical research for understanding intricacies of some disease conditions, so that we could be able to get some insights onto what to go on. I'm not going to talk so much about genomics or transcriptomics or proteomics. In fact, proteomics is the focus of the next webinar. But again, I like the scenario the moderator created for genomics. That genomics is a recipe for cooking, so it gives you the code that you need to make a diet, to cook food. And metabolomics is doing the cooking in real time, so the ingredients you need how to mix the ingredients to get what you need. And that's very, very a good analogy, because then it tells us that for genomics, the information is already imprinted in our DNA. And again, so from last week, from last 2 weeks, I didn't really get opportunity to partake, but one of the things I'm sure came up is the fact that there are some information in our DNA which could predispose pregnant women to preeclampsia. Now, the focus of today's seminar, we will be looking at metabolomics. So again, there are some metabolites, which in simple terms, I would say there are some compounds which could be produced in response to preeclampsia. And by studying these compounds, we can be able to identify potential biomarkers which are associated with the disease conditions. For example, in the last 2 slides over here, I just mentioned that some factors can be produced by the placenta, and these factors can affect maternal blood circulation. And it's been implicated, research has been shown that it's been implicated in the narrowing of the blood vessels, which causes hypertension. So if we are able to identify these factors, which are produced by the placenta, they could be used as biomarkers for preeclampsia. Now, these factors we are referring to, they are molecules, they are biomolecules. So metabolomics is one of the key approaches that we could use to identify what are some of these biomolecules and their abundance as well, how much is being produced. For the clinicians among us, one biomarker which comes into mind when we think of kidney damage is creatinine. So creatinine. So whenever a lab technician tells you that, oh, we looked in your urine and we saw elevated creatinine levels, then when the doctor or a clinician gets the results, the first diagnosis which comes into mind is there is a possible kidney failure or complication with the kidney. Another example is when a lab person looks through, a lab technician looks through, or let's say analyze your blood sample, and it comes up with, oh, you have a lot of albumin in your blood, or bilirubin in your blood, or alkaline phosphatase in your blood. And then the doctor receives this report, and the doctor sees elevated alkaline phosphatase and bilirubin, albumin, and all the gene GT. The main thing which comes into the doctor's mind is there is a possible liver damage. So again, these are enzymes or proteins or biomarkers which it gives us information about possible complications to some organs. And we are not yet there for preeclampsia, but that's where the focus is getting to gradually, that we'll get to a point where we would be able to identify some compounds which immediately we are able to find this elevated amount of these compounds in biosample. We could be able to confirm or state with certainty that there is a possibility of preeclampsia in this pregnant woman. And that's very, very important to identify the preeclampsia in very early stages, because like all disease conditions, when we are able to identify it in at the earlier stage, it really helps with treatment and successful treatment of the condition. So over here, we are looking at how metabolomics can play a role, looking at the metabolites produced in a cell or produced by the body, how we could be able to differentially identify some metabolites and say that, oh, this metabolites, when it's present in increased concentration, we could use it as biomarkers. In fact, some studies has been done, not in Ghana, but in other populations, and they've identified potential biomarkers for preeclampsia, which I'll show later. So still on techniques, advanced techniques which are being used in biomedical research. In yellow over here, we could see that preeclampsia is, we could see metabolomics is gradually becoming very popular in the biomedical research space. So for the past decade, we could see that the use of metabolomics is becoming very popular, and is slightly surpassing genomics, transcriptomics, and proteomics slightly. According to this publication, which gave out this figure. So that's also trying to tell us that if metabolomics is gradually becoming popular, then it means that the approach itself has been improved, and it's very easy to, well, I won't say easy to use, but it's something which is becoming very relevant, and we are getting very conversant with its usage. So it's becoming very popular with us. And in terms of preeclampsia, then it means we can also rely on this technique or this approach as well to be able to solve a problem at hand that is getting suitable biomarkers for the disease. And again, metabolomics looks at the metabolites which are being produced in increased amounts in response to preeclampsia. And again, if we could use metabolomics as an approach, it will really help us in getting biomarkers for preeclampsia. So this slide is just to highlight the fact that metabolomics is one of the approaches which we could use. In fact, it's currently in use in other geographical locations. Ghana, we are yet to pick it up, but which could be used, especially since the presentation is coming from Ghana, which, since I'm speaking from Ghana, which we could explore for pregnant women in Ghana to find out if there are some specific biomarkers in the population in pregnant women suffering from preeclampsia, so it could help in diagnosis of the disease condition. Now I'll talk a little bit about metabolomic analysis, but I will not go too much into detail there. I'll leave that for the second speaker to give us lots of the technicalities, but I'll give just sufficient information for us to appreciate how metabolomics can be used for biomedical research as far as preeclampsia is concerned, mainly to get some diagnostic markers and also to see how it can inform treatment of the disease condition. So as far as diagnosis is concerned, we always need a sample. In the case of preeclampsia, our sample can be blood, it can be urine, it can even be sample from the placenta or even amniotic fluid also. So these are some possible samples which we could subject to analysis by metabolomics. Now, it also means that these samples are containing some metabolites which we want to find out whether these metabolites, we could be able to identify those that are uniquely associated with preeclampsia. So in order to do that, of course, metabolomics relies on some device. Over here, we are saying mass spectrometry-based metabolomics. In previous times, they've used lots of chromatography-related techniques to be able to identify metabolites present in a sample. But I think with advancement in technology, mass spectrometry is becoming very popular. So what this also means is that when we get your sample, we can inject it into a mass spectrometer and then allow the mass spectrometer to do its work. And by doing its work, what the mass spectrometer is going to do is two things. We can tell the mass spectrometer what it should do. So firstly, we can design the experiment in such a way that will tell the mass spectrometer to tell us all the possible compounds or metabolites that are present in the sample we've delivered. And this can be tedious. It means you are going to make it do lots of work, and analysis could be a little bit complicated. But then the advantage of this is that if you feed a sample into a mass spectrometer and you tell it to give you all the possible biomarkers, if this sample is coming from a pregnant woman suffering from or diagnosed with preeclampsia, it means that if we see elevated concentration of specific biomolecules from this sample, and we have a control, let's say an healthy person, a healthy male or a healthy female who is not pregnant, or a pregnant woman who is not having preeclampsia, and we also take their sample and subject it to the same procedure, and we don't see this we see elevated metabolites in the sample from a pregnant woman with preeclampsia, we don't see that in a control pregnant woman, then it means that we are beginning to get some relevant information about possible compounds which can serve as biomarkers. So that's what is meant by untargeted analysis over here. We allow the mass spectrometer to give us information about all possible biomolecules that are present in the sample. But that can be complicated and tedious. So in order to make the work a little bit less difficult, if previous studies in other geographical locations has done analysis and have come up with some biomolecules which they think could be biomarkers for preeclampsia, we could sort of program the mass spectrometer or mass spectrometry analysis such that they try to focus a little bit more on these biomolecules which we have pre-information or we have earlier information from prior work that they may be elevated in preeclampsia. So that's something we call targeted analysis. So we are not just looking for all metabolites in a sample, but we are looking for specific metabolites which we want to validate whether they are really present in elevated amounts in the sample. So for this particular metabolomic approach, SQUAD, which is simultaneous quantification and discovery analysis, it combines these two approaches, which is the advantage of using this particular technique. But I'll end it here as far as the description of the technique is concerned. The second speaker might go a little bit more into that. Now, again, using the SQUAD approach. So, for example, I mentioned the targeted and then the untargeted analysis. So for the untargeted analysis, we determine all possible metabolites in a biological sample, which can be urine, blood, amniotic fluid, or any biosample. But then for the targeted, we are measuring specific compounds based on earlier information or pre-information we have from earlier studies that these compounds may be overrepresented or may be abundant in the sample. And again, that means that we have an hypothesis which we are testing. But for the untargeted, we are allowing the analysis to drive the hypothesis, sort of something like that. So then moving into what has been done, because looks like we are all of us are more interested in some possible biomarkers which are associated with preeclampsia. So looking at some work which has been done, in fact, extensive work has been done. We could see some metabolites, in fact, 33 of them coming up. At number 1 is creatinine, and then at number 33 is taurine. And we are also seeing EATs. So, for example, creatinine, the EATs we are seeing is appearing 7, glucose is 7. So the heat, it's giving us an information of how many times these metabolites are coming up from previous work which has been done. And in the third row, we could see which samples were used. So we could see plasma samples could be used. We could see serum samples were used, or cord plasma, or the urine. So these are possible biosamples which have been used in research to be able to identify potential biomarkers for preeclampsia. And so again, when we are looking for this, when we are analyzing samples when we are analyzing metabolites in samples, we are looking at whether the amount of these metabolites are high or they are low with reference to a particular reference value. So we always have a reference value, and then we want to ascertain whether the concentration is above or below this reference value. So this is just telling us the third and then the fourth row columns are telling us samples which were used, and then whether this metabolite, in this case creatinine at position 1, was elevated in this sample or whether its amount was reduced. And just focusing on the second row, it tells us that creatinine is one of the creatinine, glucose, isoleucine, and glycine are the very popular metabolites which are coming up. Now, coming from a biochemistry point of view, creatinine is not surprising because earlier on, when I was beginning the talk, I mentioned that organ failure is one of the main complications that can arise with preeclampsia. And I mentioned that to a clinician, when we see elevated creatinine, then what comes into mind is potential complication with the kidney. And so this is not surprising that creatinine is coming up as a biomarker for preeclampsia because it may give us an information that the elevated the high blood pressure is actually causing complication to the kidney, which is leading to elevated creatinine being detected in the urine. But again, one of the things which I didn't mention from my first slide, which I'll quickly rush to my first slide, is that there is proteinuria. So proteinuria means you have abundant proteins in the urine, which is one of the complications of preeclampsia. And ideally, we shouldn't have so many proteins or amino acids in the urine. If we do have it, it also means that there are complications with our kidney. So it's not surprising that when we come and look at their biomarkers shown over here, we are seeing lots of amino acids. Isoleucine is an amino acid, glycine is an amino acid, phenylalanine is an amino acid, carnitine is associated with amino acid metabolism, histidine is amino acid, leucine is an amino acid. So this is trying to tell us, it's confirming what the first slide is trying to say, that one of the complications of preeclampsia is having a lot of proteins in the urine. And so these are all markers for possible kidney failure. So now what the main research question is how we could be able to identify markers that can be able to pinpoint two complications that are unique to preeclampsia and not other complications. In other words, if we have someone who is having a complication of kidney disease, and we have someone who is having preeclampsia, and both of them are having, of course, they are having, let's say, an underlying kidney complication. If we could get some biomarkers which could be able to distinguish between preeclampsia and another patient who is having a kidney disorder, that will be very, very important. And in all this, we need we need lots of research efforts to be able to identify some of these biomarkers. And that's where metabolomics comes in, because then when we take samples and then we do systematic analysis of the metabolites in these samples, we can be able to get hints. In fact, people are beginning to be convinced that looking inside the amniotic fluid is much more realistic, because amniotic fluid is associated with pregnancy. So if we are able to find some elevated metabolites in the amniotic fluid compared to a pregnant woman who is not showing symptoms or complications of preeclampsia, then we can be able to get some preeclampsia specific biomarkers, which people think could be more applicable. So there is an opinion out there that using amniotic fluid or placenta or the cord from pregnant women are more ideal instead of using serum or urine or blood. Which in that case, we could get elevated biomarkers, but we cannot associate it uniquely to pregnant women. So then again, in biochemistry, when we are able to identify elevated metabolites, we try to understand which pathways are these metabolites coming from. And again, looking at this slide, it tells us amino acid metabolism is coming up a lot. So arginine is an amino acid. So arginine biosynthesis is being affected. Alanine, aspartate, glutamate, they are all amino acids. So this slide is also just confirming the fact that amino acids are coming up. Pathways involved in amino acid metabolism are being picked up for research pertaining to preeclampsia. So it's trying to give us more information that amino acid metabolism might be perturbed in pregnant women showing complications of preeclampsia. So it's also trying to help us to direct our hypothesis or research to look more into amino acid metabolism to see if we could be able to get specific biomarkers, and also how to intervene or get treatment conditions by trying to reduce anomaly in amino acid metabolism so that we could be able to help in the treatment of preeclampsia. So all of this is coming up because of metabolomics. We've been able to understand the holistic metabolites that are present in biosamples. So this is my final slides. And again, we are looking at metabolic pathways, and we could see that we have lots of extensions coming from amino acid metabolism. And I think 8 extensions coming from amino acid metabolism, 3 extensions from carbohydrate metabolism, and then translation and lipid metabolism. So all of this is pointing to a possible hint that amino acid metabolism is one of the key pathways which is being perturbed or affected by preeclampsia. And so it's also trying to now drive in our hypothesis that if we could focus more on amino acid metabolism, then we will be able to get a greater understanding of what's really happening. So this is just to say that there's been quite a number of work going on into preeclampsia, trying to understand what's happening using metabolomics. Quite a lot of work has been done, but there is still a lot more to be done. And all this preliminary information which we've obtained from prior studies are guiding subsequent work, so that we'll be able to validate some of these biomarkers which are coming up to be able to see how they could help in the diagnosis and treatment of preeclampsia. Again, so that in Ghana too, we are trying to do our best, and if we are able to get lots of funding, that's also going to give us sustained resources to be able to do in-depth analysis into complications, biomedical research related to complications of preeclampsia. So yes, we are always seeking funding from donor agencies to be able to conduct this research. But again, key message is that amino acid metabolism is one of the key pathways that is perturbed in preeclampsia. So metabolites, my final slide, I know I've been speaking for a while now, so I'll end with this final slide that metabolites involved in amino acid metabolism are the predominant potential biomarkers for preeclampsia. So this is where we are beginning to focus our attention on. And research using biosamples from the Ghanaian population is really necessary to validate these potential biomarkers because whether we like it or not, all the biomarkers I've shown earlier on, they were done using, I think they were done in Europe and I think in Asia and then in the US. Work in Ghana, we've not really looked holistically into biosamples using metabolomics. We've not done that yet. So again, then there is a need for us to be able to use Ghanaian samples from Ghanaian patients to be able to validate the biomarkers which has been reported from this other geographical location. And that's very, very important so that we could see how applicable these biomarkers are to the Ghanaian population. That's also to say that all other different geographical locations will need to validate their biomarkers in their population to know how applicable these biomarkers are to the population when it comes to diagnosis for preeclampsia. And then when we are able to do this, we can be able to make informed and valid recommendations to clinicians so that ultimately the health and well-being of pregnant women will be our ultimate priority, and we'll be able to reduce their mortality associated with preeclampsia. And with that, I want to say thank you very much. Thank you for the opportunity to speak on preeclampsia using metabolomics. Thank you.
Thank you, Dr. Ahmad. That was really interesting. Lots of questions in the chat, but we will come to it at the end of the second speaker's presentation. Thank you so much. That was really elaborate. And I forgot to take us through the survivor story. So at this juncture, we will have a survivor share his story of preeclampsia, and we are most privileged to have the CEO of APEC Ghana, Koiwa, to share his story with us. Over to you, Koiwa, and when you are done, we'll take Dr. Zhang.
Hello, thank you, Isabella. Greetings to everyone. Thank you for joining us from every part of Ghana and those outside Ghana. Also, thank you for joining us. Just to add the words and wish all women a belated happy International Women's Day. And in honor of that, I choose to share my story today. So I'm Koiwa Koilabi, popularly known as Mama K. I'm the Executive Director of Action on Preeclampsia Ghana. I'm a 4-time survivor of hypertensive disorders of pregnancy. I have suffered all the spectrum: preeclampsia, eclampsia, HELLP syndrome. Out of 4 pregnancies, I lost 3 babies. I have 1 surviving child who actually was a second pregnancy, and that was because I patronize quality healthcare in the United States. So for that second pregnancy, I did half antenatal in Ghana, and then I did partly in the United States. And in the United States, at 30 weeks, preeclampsia came in, but I was managed to up to 37 weeks, and I was delivered. But with the first pregnancy, like a lot of women, I was ignorant, irrespective of whatever education I had no idea. And so during the 7th week, I went into full-blown eclampsia. One day, sometime in October 2012, I was with my partner then, and then I was complaining of headaches, and he was like, you need to get some rest. So in view of going home and getting rest around 2 a.m., apparently I just went into had me to the hospital. On the way to the hospital, my partner then called my mom and was like, "Oh, mommy, Kwewa, saying AC," and my mother was like, "Oh, Same Yari." My husband then was quite shocked, and he rushed me to a public hospital where luckily there was a night surgeon, and he explained the condition and said, "We need to immediately deliver your, her, or she will die." And so I had an emergency CS. I had a baby boy, very tiny, less than 1 kg, so tiny. And then I was discharged after 5 to 6 days, but he stayed on an extra day, but then he died after that one day when I left the hospital. So you can imagine first time mom. We come from a society where when you get married, you must get pregnant. If the baby's not coming, society will be talking. So I was quite traumatized. But luckily, God has also blessed me with so much fertility. So 6 months on, I got pregnant again. And that was when I had a second child, whom, as I said, I patronize high quality care in the US. And she's very well now. She just returned from school and doing her homework. Fast forward, at this point, I thought I had conquered the condition of preeclampsia. So 2017, got pregnant again, and I was looking forward for Ghana to give me my baby, because at this point the funds were not so much for me to travel outside. So I decided to patronize the healthcare in my country. But sadly, this time, even though I didn't exhibit all the symptoms of headache, bloating, but I was unusually tired every time. And when I was admitted one Saturday, same weeks, 26, 27, 28 weeks, I went to the hospital just to check my BP, and it was 150, and I was put on admission. Initially, I resisted admission, but I was eventually put on it. And after being in the hospital for 4 to 5 days, the midwife comes to check the fetal heartbeats, can't hear. The matron comes to check, can't hear. And then the clinician comes and said, Kwewa, I'm sorry, but we lost the baby. At this point, some of us, when we are traumatized, we are more quiet than we are loud. So I just asked the doctor how fast we could get that dead fetus out of my womb, and he said, "Oh, we could do induce me to deliver." That didn't work, and so they took me back to that cold theater room. For those of us who have had cesareans or been in the theater, that very cold theater room, and cut me open and brought out a dead fetus, and I came out of that surgery with so much pain, but with no baby to compensate my pain. It was at this juncture, after this third experience, that during my 6 weeks postpartum, I was just online and I was exploring and trying to find who to talk to. What have I done so bad that I couldn't a child, a sibling? Why is this condition defeating me? And in my research online, because at this point, mind you, I was still in pain, all I saw was academic publications and papers, and that was not what I was interested in. I wanted somebody who could relate to the repetition of the condition, why I'm having it, like just something. So I expanded my research, and then I got to get some patients advocacy organization in Australia. And then I started having a conversation with them that this is me, I'm from Ghana, this is my situation, this is the third time I'm having it, I've lost 2 children, I was a bit traumatized. So they took me through some engagement, some discussion session for the period of 6 weeks. And after that, I was very grateful. I mean, I was not totally healed, but I was grateful because it didn't look like I was alone, or I was a cursed woman, or I was special in some way that I couldn't give, my daughter a sibling. So it was from that I took inspiration, and I told them that, well, when I was looking for a patient advocacy within my setting, I couldn't find it. So with your permission, I would like to do something similar in the Ghana context. And that is how Action on Preeclampsia started, where I had the opportunity to go on radio to share my story sometime May 2017. And through that platform, I had some survivors joining me, including, those in Kumasi, some in Accra, who joined me for us to sort of create this movement and try to create awareness about hypertensive disorders of pregnancy. So what started as a WhatsApp platform with a whole lot of survivors and other education, clinicians to educate us, is what has became an NGO 1 year on in 2018. And then this year will be 7 years in May 2022. So at this point, I was like, oh, I had read all the books, I had read the science, I was working with researchers, because through the organization, I learned a lot. I remember my former partner then asking me, is it that I want to create a weeping party, or I really am on a good course? And so it was a good time having to work with a lot of researchers, even our partners that we are working on with right now. And then somewhere 2019, I just decided to give it a try again, with the hope that, this time the baby will come, because there was no ignorance. I was aware of all the monitoring mechanisms. I knew top-notch researchers. But then 2019, well, I conceived right again, 27. This time, I did not only suffer preeclampsia, I had HELP syndrome, and they had to immediately deliver me. So baby Grace is the one whose picture you see on the screen in the middle. There was so much hope for her, but baby Grace died 3 days after delivery. She was so small, and the facility did not have an emergency medicine surfactant on the site to be administered to her to increase her chances of survival. So for me, when I always share my story, I say that Ghana has yet to give me my baby. I have a baby because I patronize quality healthcare somewhere, but that should not be the case. And I know some women who have had much success story than mine in this context. And so the fight still continues that we want to understand this condition, we want to mitigate it, we want to reduce the mortality associated with it, because indeed no woman should die giving birth, and every child deserves a chance at life. Thank you, Isabella.
Thank you so much, Koyewa. Thank you for sharing your heartfelt story with us. And this is why this course is ever so important, that we can get to know more about preeclampsia, get to understand all the pathological mechanisms surrounding its development in efforts to actually do better for women, improve the quality of care, and save more lives. Thank you so much. At this juncture, we'll hand over to our second speaker. We have lots of questions in the chat. Please keep them coming. But we'll hand over to Dr. Zhang to take us through his presentation, and then we'll take all your questions after that. Thank you so much. Over to you, Dr. Zhang.
Thanks, Isabella. Can you hear me? Is my audio okay? Hi, can you hear me? Is my audio connected?
Yes, we can hear you.
Thanks. I'll put on my slides a moment. Is my slides visible right now?
No, not yet.
Not yet.
Okay.
Yes.
Yep,
Yeah.
we can see.
Yeah. Thanks. Hi everyone. Thanks for having me here on this very important topic. So I come from a bit slightly different topic. I'm Yong Liang Zhang from the Institute of Risk Assessment Sciences at Utrecht University in the Netherlands. So my previous research mainly focused on environmental studies. So today I will talk about the application of high-resolution metabolomics in environmental research and its potential for preeclampsia. So first, I think I would like to go through the concept of metabolomics. So the mainly or widely accepted concept is the comprehensive analysis of all the small molecular weight compounds in a biological system. So no matter it's measured in the blood, in the urine, plasma, nasal swab, or any other samples. So the metabolomics is usually divided into two groups. So one is the targeted metabolomics, so where a known set of metabolites were measured, so with a reference to a standard. So which means you know what you are looking at. You know what metabolites you're looking at. So it's more like hypothesis-driven research. It can be used for biomarker research. It can be used for clinical diagnosis and other purposes. And another emerging topic is the untargeted metabolomics. So it would enable us to detect hundreds of thousands of metabolic signals. So, but you do not necessarily know what the chemical identity of these signals. So it's more used for hypothesis-driven research. It can be used for discovery of novel biomarker or biological pathways that are associated with the questions you're looking at. The workflow of high-resolution metabolomics, which is the topic I will focus on today. So the workflow is usually involved in first is the hardware. So it ranges from the sampling to the separation, so chromatographic separation. So it first goes through a column where you can separate a molecule, separate all the molecules within the samples, depending on their molecular weight, their polarity. So whether it's positive, is more whether the chemical is polar or more affiliated to or having positive charge or negative charge. And then you will go through the ionization stage where you will be adduct. So to give it a charge before running through high resolution mass spectrometry. So then you will go through the feature extraction from with all the raw data from the mass spectrometry. So it involved in feature picking, complementation, the peak alignment, and then finally data cleaning and normalization. So which is after feature separation, it can be used for health-oriented research. So which is the statistical part. So we can use the data to link it to external exposures or a health outcome. In the topic of today, I think it's would be the presence of preeclampsia. And also another important part of the high-resolution metabolomics is the compound annotation. Because we are looking from the hardware, we are getting hundreds of thousands of metabolic signals, as you can see in the picture in between, the picture B. So, but only, but we only about thousands, where thousands of those signals we know there are libraries that we can annotate thousands of known metabolites. So we are looking at far more. So the unknown metabolites is far more than metabolic signals that are known. First, I would like to showcase the application of metabolomics in occupational exposure to benzene. So this study by Rossman and his group analyzed the exposure of benzene and its and the metabolic changes in plasma and urine. So they have identified 99 benzene metabolites, of which 13 were known benzene metabolites and 86 were putative or predicted benzene metabolites. So which is being matched by which is predicted by matching the data from the mass spectrometry to the database that's available. So this is the matching was more based on the mass to charge ratios, which is more putative matching. So they have identified many metabolites that were associated with benzene exposure, and this network map network analysis and showcase the metabolic pathways that were associated with benzene metabolites with benzene exposure were being linked to hematological changes, including the blood metabolites, the chromosome abruption, and other changes in the system. And another example is a recent example is the coffee consumption and Parkinson's disease. So the risk of developing Parkinson in later life. So the sampling of this study were 8 years before the diagnosis of the Parkinson's disease. So the exposure was measured before the disease happens. So in this study, the researchers used the high resolution metabolomics, so which extracted about 18,000 features and matched to the database to identify and have successfully identified 12 unique caffeine metabolites. Of those caffeine metabolites, 4 of them, so caffeine, and 3 of its metabolites were inversely associated with the risk of Parkinson's disease in later life. And another application is widely application in the research of air pollution exposures. So more precisely on the ambient air pollution exposures. This is results from a recent review work by Liang from Emory University in the US. So they have identified over 800 metabolites that were associated with either of the exposure or either of the components from the air pollution. So the figure to the left showcase 35 metabolites that were repeatedly being reported in over at least 5 independent studies. And the figure to the right are the showcase 62 biological or metabolic pathways that were associated with the exposure to either of the ambient air pollutants. Then I'll move on to the application of high-resolution metabolomics and household air pollution with one of my research projects as an example. So household air pollution has been a universal and also a global problem. So it's also an important problem because it's over about 1/3 of the global population are still relying on the polluting fuels or solid fuels for domestic purposes, and those application of those polluting fuels have give rise to household air pollution that resulted in very huge house burdens, and which is one of the cases. The study region that my project was carried on in southwest China, in Shuangwei and Fuyang County, where lung cancer rates were exceptionally high. We were looking at and the exception, those lung cancer rates were later associated to the use of polluting coal for daily purposes, so locally sourced smoking coal. So the users of these type of coal were being associated to up to 100-fold risk of lung cancer among non-smoking women. And our recent work have looked at the exact pollutants within those coal smoke and associated to the lung cancer risk, and we have identified a group of the 25 polycyclic aromatic compounds, so PAHs, that were associated with the highest risk of developing lung cancer in later life, and of which, so 5 methylcrysins, which is a component within these 25 PAHs, is having the highest individual risk. So we also applied a metabolome-wide association study within this population. So and associated to 6 clusters of exposure. So a total, we have measured a total of 42, 43 individual individual pollutants and clustered those 40 chemicals into 6 exposure clusters. So the top left, so the pH 31 cluster contains a group of 31 polycyclic aromatic hydrocarbons. So it has been associated to the most or the highest number of metabolic signals, which is inconsistent with our previous finding where a large group of pHs was associated with the highest risk of lung cancer among the exposures we have tested. And also, the follow-up analysis, so the pathway enrichment have indicated a total of 22 metabolic pathways were being disrupted or associated with either of the exposure clusters or the dichotomous exposure of the fuel. And also we have, when comparing the enriched metabolic pathways to, because in this study, we're looking at household ablution. So when comparing the pathways being enriched in this study to the pathway being enriched in the ambient ablution studies, we have identified one unique metabolic pathway that's unique for household ablution, which is aspartate and asparagine metabolism. So, well, there are merits for application of high resolution metabolomics in environmental research because it can help us generate new hypotheses and for risk for various purposes. But there are also various challenges remaining across all the working steps. So one is the statistical challenges when handling the higher dimensional data set, because for high resolution metabolomics, we are looking at tens of thousands or hundreds of thousands metabolic signals, but we only have hundreds of samples. Studies analyzing over 1,000 samples are very, very few. So another challenge is the annotation. So because we're looking at so many metabolic signals, so it's really difficult to identify all the metabolic signals. So in my previous in the MWAS study I presented earlier, we detected over 30,000 features, but 30,000 metabolic signals, but we were only able to annotate or identify the chemical name of close to 1,000 features or close to 1,000 metabolic signals. And also another thing I want to point out is the pathway mapping, because current pathway mapping is more focused on endogenous metabolic pathways. So it's not being unique. It's not the database is not unique to exogenous exposures as well. So if we are looking at if we are studying exogenous exposures, so the environmental exposure or other modifiable exposures or factors, we would the database for metabolic pathways is not complete. So we may end up with similar metabolic pathways when we're looking at various different exposures. And also there are many other challenges exist in all the workflow of high resolution metabolomics. Yeah, talking back to the topic I mentioned earlier about the annotation. So because for targeted where we will only be able to measure close to 1,000 metabolites, but with high resolution metabolomics, we are looking at hundreds of thousands of metabolic signals. So although there are many databases that's available, currently available, but the lab-to-lab differences even though each lab has their would have their in-house libraries, it's really difficult to communicate between the data coming out from different labs, and also to have a universal applicable database that we can that we can use to identify expand the coverage of annotation capacity for the high resolution metabolomics. And although there are challenges and challenges exist for high resolution metabolomics, it do have its potential for researching preeclampsia. So one is for biomarker discovery, because we're looking at many many signals we haven't measured before. So we would potentially be able to measure to identify some of metabolic signals that can be used for any diagnostic purposes, for prediction and also prognosis of preeclampsia, and also for the discovery of the pathophysiological process of preeclampsia that can be used for precision treatment or precision treatment. And also we can also use it to identify modifiable risk factors for preeclampsia that can be important for early prevention. This is my presentation. Thanks.
Thank you so much, Dr. Zhang. That was very precise, and yeah, lots of slides, lots of information, but yeah, we've learned a lot. And there are a few questions from the chat that I will start with. I'll start with you, Dr. Ama. The first question somebody was asking is, hold on a sec, let me check. So the first question somebody is asking is, what are metabolomics? And just generally, how is it used in medicine? So I guess that person may have missed the first bits of your presentation. If you can just summarize in like 2 minutes.
Thank you very much for the question. So what is metabolomics? Metabolomics is an approach that helps us to investigate the complete set of biomolecules in a sample. These biomolecules could be proteins, could be carbohydrates, could be amino acid, or it could be some compounds which we are yet to know the structure of. So, for example, if we follow the presentation from Dr. Zhang, usually for some of the compounds, we would also need to annotate it and be very sure of their structures as well, because maybe they are not very common and popular structures. So we getting to know all the possible compounds that are present in a sample, a biosample, is what we refer to as metabolomics. How it can be applied in preeclampsia. So if we are able to get a sample from a pregnant woman having a complication of preeclampsia, and we subject it to metabolomic analysis, like again we heard from the second presentation, if we do some untargeted analysis, then it helps us to have an idea of all the possible metabolites that are present in that sample. And if there are metabolites that are overly represented or overly abundant in the sample, then that could be giving us cues to possible biomarkers for preeclampsia. So in short, this is the very simplified explanation I could give. Thank you.
Thank you so much. That was really precise. Over to you, Dr. Zhang. Someone is asking, well, I don't know if you can really speak to this, but you can try. Do we have the capacity for metabolomics in Ghana in terms of instrumentation? Or maybe speak more from the standpoint of, do you think in LMICs we have capacity for metabolomics in terms of instrumentation?
I'm also very new to the topic of preeclampsia, but for the untargeted metabolomics. So I'm not sure if the current capacity in Ghana right now. So, but for the analytical part of high resolution metabolomics, I think is quite achievable. So because if we analyze the samples, mostly when the lab would analyze the sample and provide us the data. So if we have the data, we can process or analyze it against the outcome that we are of interest. So that's more relatively easier to achieve, I think, for capacity building. But I'm not sure how what's the current status of instrumentation for high resolution metabolomics in Ghana. So I'm sorry, I cannot give a very quick answer to this question.
Dr. Ahmad, do you want to add your voice to this?
Yes, thank you for the opportunity again. Instrumentation for metabolomics in Ghana, to the very best of my knowledge, we do not have the instrumentation for now. What we do have is some collaboration is beginning to develop. And again, I'm very happy Dr. Zan is present on this platform. Maybe I would engage him after this presentation. So we are trying to develop some form of collaboration so that we can work together to be able to try to have a comprehensive understanding of the circulating biomarkers in preeclampsia patients in Ghana. Of course, the getting the samples, once we do have ethical clearance, we already have pregnant women who are willing to give samples because they want to contribute to our understanding of the complication. And again, we also understand some of the basic techniques and principles underlying metabolomics, and there has been some discussions going on. But as far as the instrumentation is concerned, we don't have funding for the instrumentation for now, but we are looking at developing collaborations to be able to initiate it from there. And then maybe later on, when we are able to raise enough capital, we will be able to get the instrumentation here in Ghana. Thank you.
Thank you very much for those elaborate answers. Someone is also asking, what is the minimum number of metabolites in the panel one must get to say, like, or to arrive at a diagnosis of preeclampsia?
If I would give a quick answer, then maybe Dr. Zan can follow. Usually when we are doing this type of analysis, we have samples from the pregnant woman having the preeclampsia complication, and then we do have a control sample. And then so it's more like a comparative analysis. So by doing this form of analysis, we don't really look at absolute values, whether the number is supposed to be 1, 2, 4. But then by doing comparison across a number of biosamples, it gives us some indication as to, oh, okay, this is the reference value for this biomarker in a control sample. But then when we get to a pregnant woman showing complications of preeclampsia, for this particular biomarker, the value goes very high compared to that. So currently, this is what we are looking at now. And then maybe, like again, Dr. Zan presented, later when we are doing some advanced analysis, then we could focus on some absolute values to be able to validate what we already have. But for now, we just do comparisons with control samples. Yeah.
All right, Dr. Zan, do you want to top up that answer?
Yeah, for the current, because if we use the high resolution metabolomics, if we want to, I think this question is linked to the diagnostic, how the preeclampsia is being diagnosed, and whether this and how this could be diagnosed with the biomarkers only perspective. So if we look at the metabolomics only, so because if we use high resolution metabolomics, so it could be the case that we are getting way more, or a couple of tens or a couple of hundred metabolic signals that can be used for prediction of preeclampsia, or to be used for diagnosis of preeclampsia. So it's really hard to tell at this very moment the exact number of.
Sorry, Dr. Zhang, we seem to have lost your audio. We can't hear you at all.
What about now?
Yes,
Yeah,
we can
yeah.
hear you now.
Yeah, so so overall, I think it's difficult to tell the exact number of metabolites that's needed for diagnosis of preeclampsia, but this is I think this is a very good start. So because if we can identify features or metabolite signals that has potential for diagnosis or prognosis of preeclampsia, we can then move from there to find which one or which group of metabolites that's most sensitive and have abundant specificity as well.
Okay, thank you so much. And the last question, I think we have a varied audience, and some members of the audience are pregnant women, or they're just people who want to know more about preeclampsia. And so somebody is asking that how do I develop preeclampsia in the first place? Does metabolomics answer that?
Thank you. Let me attempt to answer that. Does metabolomics answer how like your being the risk factors associated with preeclampsia? No, not directly. Genomics actually is best placed to identify potential factors that predisposes a population to preeclampsia. Because then we could be looking through family history, we could be looking through the DNA to see if there could be some genetic signatures or sort of mutations that may be involved. What metabolomics does provide is it gives us information on what is happening in real time in a pregnant woman having preeclampsia. And it also provides information on, aside like biomarkers, information on how we could be able to administer pragmatic treatments so that metabolic pathways that have gone haywire because of preeclampsia, we could be able to administer suitable medications to be able to control or bring these pathways to the normal state. So that's where metabolomics may come in. But identifying risk factors, no, genomics is best placed for that, to the best of my knowledge.
Well, thank you very much. Yes, Dr. Zhang?
Yeah, I would also like to add a remark on this, because I think metabolomics is a very powerful tool to link external exposures to the disease outcomes. So, because for preeclampsia, there's also research on how environmental factors can contribute or lead to increased risk of developing preeclampsia, because we're all exposed to various different environmental factors. So the metabolomics can help us understand how the different environmental factors is contributing to the increased risk. So that's something we can look at as an angle. So using metabolomics, we can understand how the process is.
Thank you so much. This has been a power-packed session, lots to unpack, lots of learning that has gone on. Thank you so much to the wonderful audience for keeping your questions coming, and thank you to our speakers for making time to be with us. It's just been mind-blowing. Next slide, please. So let's do a little recap. What have you learned? What is your one takeaway from today's session on metabolomics? If you can go to the chat box and type your thoughts, your learnings there, that would be great. So I think that I have learned that, at least from learning about metabolites and their pathways and all of that, we can detect early signs of preeclampsia even before symptoms appear. And as a clinician, I feel that that is super duper important, especially because with preeclampsia, the sequel of the disease is very unknown, and it can go from really minor symptoms to very severe in a very short while. And so identifying women early is actually very key to improving the outcome. Jeffrey says his takeaway is that there's a lot of very smart people who are doing the best to look into complications more accurately. So thank you to Dr. Ama, and thank you to Dr. Zhang for your ongoing research and your work in this area. as you're typing in the chat, also let us know, are you joining us for the third Knowledge Cafe? So we are still continuing with our omics of preeclampsia. We've done the genomics, we've done the metabolomics today, and in a short while, in about a fortnight, we will look at the proteomics. Okay, Gabriel says this is his first Knowledge Cafe. Gabriel, has it been useful? Have you learned anything? Is it something that you feel you will join us again for, or you're going to share with your network for our next webinar? And Selena says, is there any way to connect with Dr. Amma for possible collaboration? I think Dr. Amma would be on LinkedIn. So Selena, look him up on LinkedIn. So thank you so much. And next slide, please. So please follow us on our social media pages. We're on Facebook, we're on Twitter, we're on Instagram, and we are also on WhatsApp, and subscribe to our newsletter. Now, the thing with our newsletter is that it's very informative. We have different sections that meet the needs of clinicians, of women, and even of researchers, because we have a research spotlight. So kindly subscribe. Our 15th edition is the most current one. Kindly subscribe and receive the newsletter fresh off the shelf whenever we release it. And you can scan the QR code to have access to the newsletter. The next slide, please. You can also join our WhatsApp community by scanning the QR code, and please give us feedback. We appreciate your feedback. We use it to refine and make things better for the next time. So please give us your feedback also about the last Knowledge Cafe on genomics and this one on metabolomics. And for MDC and NMC accreditation, please scan the QR code also. The next slide, please. So we always invite people to partner with us, to collaborate and to sponsor. For sponsorship or donations, please, you can send it by Momo payments or by bank payments to the accounts listed on the screen. And this money will help us continue our advocacy work, our research work, and just general education that APEC does for many pregnant women across the country. Our community engagement programs are all sponsored through your kind donations. So please keep it coming. If you want to reach out to us, our email address is on the screen. Our WhatsApp number is also on the screen. Next slide, please. So a big, big thank you to the planning committee. You have been instrumental in making sure that all these sessions, all these knowledge cafes come to fruition. So we want to thank all the members of the planning committee for the hard work, and hopefully we'll keep more interactive and more interesting sessions coming your way throughout the rest of the year. And as I mentioned, one of our main partners is the Sports Study. So a big thank you to the Sports Study for continuing to partner and stand with us as we deliver these webinars to many people, not only in Ghana, but across West Africa and across the rest of the world. Next slide, please. So as we do, our APEC tradition is to take a selfie at the end of each webinar. Many people have their cameras turned off, but I guess a few people would like to be in the selfie. So if you don't mind, turn your camera on, you give a big smile, and then we say 1, 2, 3, and Jeffrey will take the shot for us. Jeffrey, are you ready?
Just give me 1 second.
All right, because I don't see everyone.
Yes, let all the faces appear before we take the shot.
Cool.
Let's maximize it as much as possible. Just a minute.
Thank you to everyone who is typing in the chat. Olivia, we will advertise on our social media pages when the third part of this series is happening on proteomics. So keep an eye out. Betty, thank you for joining. Gertrude, thank you. And Lazarus says, it's my first Knowledge Cafe. Thank you, Lazarus, for joining, and we hope to see you in many more. Give us a sec to sort out
Oh, I have taken the
screen.
shots.
You've taken the shots? Oh,
Yes, I have.
all right. Okay. All right. So on behalf of myself and Jeffrey, my co-host, thank you so much for joining us for this session, and we hope to see you soon. Bye.
Jeffrey has gone.
Woman, I see a woman. Every day in the mirror, I see a woman. And every time I look in mama, I see that woman. A wonderful woman, an African woman, mother of nature. Beautiful woman. Beautiful woman. Me oba, bibi ni ba. Semiga senshio yenshia neyenza. Me was suba wa, but you're my one vet to say.